Imagine this. Beneath a frozen moon, over 800 million miles from Earth, lies an ocean larger than Earth's that might be alive. Not science fiction. Real NASA data. And that moon isn't. Chapter 1. The moon. No one paid attention to it, didn't stand out, it wasn't massive, it didn't glow with promise. Even NASA's early missions didn't give it much thought. But that all changed in 2005. That's when the Cassini spacecraft arrived. And almost by accident, it spotted something strange, something impossible. Near the moon's south pole, geysers of water vapor were shooting out from the surface. At first, scientists weren't sure what they were seeing, but the data kept coming in. Massive jets of vapor and ice particles were being expelled from beneath the surface, forming a kind of icy halo around the moon. That discovery flipped the scientific world upside down. You see, geysers don't just happen on frozen rocks. They need heat, they need pressure, and they usually need water. Not just frozen water, but liquid, flowing, alive, in a sense. Suddenly Enceladus wasn't boring anymore, it was active, it was mysterious, and it was hiding something deep beneath its frozen shell. Cassini was never meant to explore this. It didn't have drills or landers for icy moons, but it did have instruments that could sample the material being ejected into space. So that's exactly what it did. On several flybys, Cassini dove through the geysers, racing through streams of frozen vapor, collecting data in the split second before the particles scattered into space. And what it found changed everything. The plumes weren't just steam, they were full of salt, silica, ammonia, and organic molecules, the building blocks of life. Cassini even detected tiny grains of icy rock, suggesting that deep inside the moon, there was hydrothermal activity, something you'd expect to find at the bottom of Earth's oceans, not 800 million miles away. It was like Enceladus had been keeping a secret for billions of years, and now it was whispering it to us through cracks in the ice. Think about that for a second. A moon smaller than England, orbiting a gas giant in the freezing cold, is blasting water and organics into space, and we just happen to be there to see it. That's not science fiction. That's our solar system, and it's very real. Before 2005, Enceladus wasn't even on the map for most planetary scientists. Now, it has one of the most promising places in the entire solar system to search for alien life. Not because we want it to be, but because it keeps giving us clues. Because it keeps showing us signs. Something is happening beneath that ice, and it's time we started listening. For the longest time, Enceladus was just another icy speck orbiting Saturn, a frozen, forgotten moon drifting in the shadows of giants like Titan or Jupiter's Europa. Chapter 2. A hidden ocean and signs of life. So what's really beneath the ice of Enceladus? Cassini gave us more than just vapor trails. It gave us a map, a rough one, but enough to start piecing things together. Using gravity data and thermal imaging, scientists discovered that Enceladus isn't just a frozen block. Beneath its surface lies a global ocean. Not a small pocket of water, not a few underground lakes, but a vast, salty ocean stretching beneath nearly the entire icy shell. Think about that. A moon that, from the outside, looks like a snowball, is actually hiding an ocean world. And not just any ocean. This one may be in direct contact with a rocky core. That's important, because when water meets rock, things happen. Chemical reactions, heat exchange, the kind of activity that can power life. On Earth, we see it at the bottom of our deepest oceans in hydrothermal vents, where boiling water jets from the seafloor, rich with minerals and chemicals. No sunlight reaches those places. No plants, no photosynthesis, but life thrives there anyway. Strange alien-like creatures gather around the vents, feeding off the chemical energy alone. If life can exist there, with no light and intense pressure, could it also exist inside Enceladus? Many scientists believe the answer is yes. In fact, they think Enceladus checks off the three major requirements for life as we know it. First, liquid water. That's confirmed. Second, a source of energy. Hydrothermal activity likely provides it. And third, organic molecules, the chemical building blocks of life. Cassini found those in the plumes. That's a trifecta. That's the Holy Grail. But here's where it gets even more intriguing. The ocean of Enceladus. It is connected to the surface through fractures near the South Pole, what scientists call tiger stripes. These cracks act like pressure valves, releasing water vapor into space. And that means one very exciting thing. We don't have to drill through 30 kilometers of ice to sample what's inside. Enceladus is literally spraying its secrets into space. That makes it one of the easiest ocean worlds to study. All we need to do is fly through the plumes and collect. And that's exactly what Cassini did, over and over again. The samples weren't perfect, the instruments weren't built for biology, but they were good enough to raise the biggest question of all. Is something alive in there? We don't have proof. Not yet, but we have everything else. The ingredients, the energy, the chemistry, and most importantly, we have access. Enceladus is inviting us in. Quietly, consistently, patiently. It's not screaming for attention. It's just breathing beneath its shell, waiting for someone to listen. Maybe, just maybe, we already are. Chapter 3. Breath from the Deep. Strange clues. When Cassini flew through the plumes erupting from it wasn't just collecting particles, it was listening. Every grain of ice, every trace of vapor held a message from the deep. And as the data came in, it started telling a story. One of the most surprising discoveries was molecular hydrogen. That might not sound exciting at first, but in the world of astrobiology, it's a massive clue. On Earth, certain microbes, primitive, resilient life forms feed on hydrogen through a process called methanogenesis. We didn't need to land, we didn't have to drill, and sometimes that's how all the biggest discoveries begin. With clues, with puzzles, with whispers that don't make sense until they suddenly do. Enceladus is handing us its secrets, ejecting them into space, letting us collect samples with a passing probe. No other ocean world makes it this easy. No other place is this generous. The moon doesn't shout, it doesn't glow. It just breathes gently, rhythmically through cracks in its surface. A quiet invitation. They combine hydrogen with carbon dioxide and produce methane. It's a simple form of metabolism, just chemistry. And if that same hydrogen is present inside Enceladus along with water and heat, then the conditions for similar life could be there too. But it didn't stop there. Cassini also detected tiny grains of silica particles that only form when water interacts with rock at high temperatures. That suggests the presence of hydrothermal vents at the bottom of Enceladus. Now this hasn't been confirmed, but if it is someday, that would be huge. On Earth, HCN is believed to have played a role in the origin of RNA, one of the key molecules in all known life. So, its possible presence on Enceladus could mean that the building blocks for life aren't just there, they're reforming, interacting, evolving. That's speculation, of course, but it's based on real, growing evidence. In other words, the ocean isn't just sitting there, it's active, it's warm in places, it's circulating, it's interacting with the moon's rocky core. That's more than just liquid water. That's a living system, in the geological sense, a place where energy and chemistry meet in ways we recognize from our own planet. And then came a more recent twist. In late 2023, some researchers suggested that certain patterns in Cassini plume data might hint at the presence of hydrocyanic acid HCN. And here's what makes all of this so remarkable. We haven't found life yet, but we have found its ingredients. We've found heat. We've found chemistry. We've found energy. Chapter 4. So why has no one gone back? With everything we've learned in underground ocean, hydrothermal activity, organic molecules, you'd think Enceladus would be swarming with missions by now. But strangely, it's not. Since Cassini, no spacecraft has returned. There's no lander, no orbiter, not even a follow-up flyby. In fact, Enceladus is considered one of the top priorities in the search for life in the solar system. There are serious ideas for new missions, flybys that could sample the plumes with sharper instruments, landers that could study the tiger stripes up close, even that might one day melt through the ice and explore the ocean directly. The technology, it's almost there. What's missing is funding and the will to act. But space is slow. Space is expensive. Agencies like NASA and ESA have to choose where to invest time, energy, and billions of dollars. And for now, missions like Europa, Clipper, and Mars Sample Return have taken center stage. And the question is why? It's not because scientists aren't interested. That doesn't mean Enceladus is forgotten. Far from it, because missions don't just need blueprints, they need momentum. And momentum often comes from people, scientists, storytellers, curious minds asking the same question over and over. Why not now? Cassini wasn't built to find life. It had no microscopes, no sterilized collection arms, no drills. But it may have gotten us closer to alien biology than anything that came before it. Back to a moon that's still whispering beneath its ice, waiting not for attention but for someone to truly listen. And it didn't even try. Imagine what we could do if we actually tried, if we built something with one goal in mind, to answer the oldest question we've ever asked: are we alone? Sometimes the greatest discoveries aren't made by going farther, they're made by going back to a place that quietly opened a door. Chapter 5. If there is life there, what then? Let's imagine for just a moment that we find it. Not aliens with ships or signals, but something small, a molecule, a cell, a chemical imbalance that suggests something is living, or was. For generations, we've believed that life was rare, that Earth was special, a lucky accident in a vast, silent universe. Because if life happened twice in the same solar system, just two tiny worlds apart, then it probably happened millions of times across the galaxy. Life wouldn't be an exception, it would be part of the pattern, a feature, not a fluke. And we'd no longer be the only story. But if life also emerged on Enceladus, deep under ice in total darkness, without sunlight or air, then maybe life isn't rare at all. Maybe it's about being connected, part of something much larger, much older, and far more mysterious than we ever imagined. Maybe it's written into the laws of chemistry. Maybe wherever there's water, energy, and time, life finds a way. What would that mean? It sounds like a scientific milestone, and it is. But more than that, it's a shift in perspective. That would change everything. That can feel humbling, even unsettling. But it's also beautiful, because maybe our place in the cosmos isn't about being unique. Not in the way we expect. Not loudly, but quietly, patiently, breathing through cracks in ancient ice. Waiting. Not to be found, but to be understood. Enceladus won't give us all the answers. Not yet, but it's offering something else, a question, a doorway. You'll help answer it. A gentle signal from beneath the ice, telling us there's more out there if we choose to look, if we're willing to go back. So next time you glance up at Saturn in the night sky, just a pale yellow dot from here, remember, one of its moons might be alive. If this video made you think about distant oceans and ancient secrets beneath the ice, hit like, subscribe, and leave a question you'd want humanity to ask the cosmos.